Hey, hello. Welcome to Advanced Algebra 2. Here we are in the second learning target. You may notice that we skipped the first one. Talking about intervals today. And this is really cool because the old way you're used to writing sets is with that set builder notation, like I highlighted there, with like x such that -5 less than or equal to x less than or equal to 6. And the new way is interval notation, which is just a couple numbers with a comma in between them and some sort of parentheses sort of thing on the outside. The other bit I highlighted. Now, right below here I've got 7 examples of different types of interval notation. And it kind of covers all the bases. Like the top one there is if they're strict inequalities, meaning they don't hit the endpoints, then you're supposed to write it with parentheses. And like the second one says, like if the left side includes the endpoint but the right side doesn't, then you got a little bracket for the one that includes the endpoint and a parentheses for the one that doesn't. And then the next 4 are all the different kinds of inequalities that aren't in a sandwich. So like a greater than, and like a greater than or equal to, and a less than or equal to. And the bottom one is my favorite. It's R. And that's just negative infinity to infinity. So you got some things going on here. And what I need you to know, at least to come back and look at later with the, for the purpose of helping yourself out after seeing some examples, is I've got these 5 bullets of different rules going on. And you're going to need to know them, but then again, they don't make any sense now because you haven't seen examples yet, so the examples really help. So these 5 things, put them off on the side in your mind, that along with the examples I just showed you, together you should be able to put together interval notation. It's a little bit harder on the brain at first, but it does give you less work to do, really, and that's super awesome. So, let's do an example. Nope, we're not doing an example. I'm so sorry, because if we did examples now, all we would have is stuff for like domains and ranges, and that's totally awesome, except, and can be written with intervals, except that it gets boring fast. So, we will have that practice built into the homework, but we should also talk about increasing and decreasing. So, a function is increasing if when like a number a is bigger than another number c, then the function at a is more than the function at c for all the points in the interval. And then it's decreasing if when like a is bigger than c, like last time, but this time the function at a is less than the function at c for all the points in the interval. And then, well, the next paragraph says that's actually a lie, because functions are increasing at points if you can make a neighborhood around the point, and I'm seriously getting a headache trying to talk through this, and I can't imagine how terrible this sounds to you. But the truth is, it's not that bad. So, one thing, the intervals of increase and decrease do not include the endpoints. And I mean that so much that I triple highlighted that right here, which actually makes it hard for you to see. Oh well. So when we do this, you'll see that the endpoints are not included. Let's do one. Ooh, look at that graph. Now that right there, friends, is a beautiful graph. So we've got this graph that goes and then so intervals of increase. There's one area where this function is increasing, and I highlighted it for you, and that is between 3 and 6. So these intervals are only the x values. It's actually said that in the last paragraph, but so it starts at 3 and ends at 6. Well, okay, it doesn't actually start at 3. It starts after 3, and then it doesn't end at 6. It ends right before 6 because the intervals never include the endpoint. The intervals of increase and decrease never include the endpoint. Okay, so that's increase. So let's get rid of that. So for decrease, well, this one's decreasing twice, right? The first one's like, and the second one's like, so it's decreasing from -3 to 3, and then it's also decreasing from 6 to 9. So it can decrease more than once. Okay, Not so bad, but let's get rid of it. Okay, next one. Oh, this graph's awesome because it has open dots, and it starts by going up, and then it goes over, and then goes up some more. So, increase, it's increasing twice. So it's increasing from -3 to 3, also increasing from 7 to 9. The decrease is, well, oh yeah, it doesn't decrease because it never goes down. Okay, yep, never goes down, doesn't decrease. Sounds good. Okay, so let's graph y equals x squared. Pretty basic, pretty boring parabola. On the right, and then on the left, and you've got yourself the parabola. So, increasing. Now this one increases on the right half, meaning it starts increasing at 0, and it increases forevermore afterwards. So it's from 0 to infinity. Well, okay, it's from 0 toward infinity. Okay, it's actually increasing just after 0, going toward infinity, meaning it's forever increasing. So 0, infinity. Soft on 0, meaning the parentheses on 0, because your intervals always are soft. And then infinity is soft with parentheses because, well, anything in intervals with infinity has the parentheses instead of the bracket, because you can't get there. That's not a direct challenge to you, dear listener. That's just reality. Please don't try going to infinity. You won't show up to class tomorrow. It's no good. Okay, decrease. It's decreasing on the left half. Now, I know it's a little tricky because the arrow looks like it's going up, and you're thinking that's going up. But the truth is you have to look at these as going from the left to the right. From the left to the right. And this graph on the left, the part that's highlighted in orange, is going down as we go from the left to the right. And so it's decreasing from -infinity to 0. Well, okay, it's decreasing for all negative numbers up until right before 0. But we write -infinity to 0. Okay, next one. Y equals -2x plus 4. It's a line. It's slope of -2. It's got a y-intercept of 4. It's kind of boring to draw. I'm sorry I didn't use a straight edge like you should. This is drawn on an iPad screen, and I find it impossible to draw with a ruler effectively on an iPad screen with the capacitive touch and, oh well, whatever. Okay, so it's increasing. No, it's never increasing. It's always going down. Just like the left half of that last parabola is going down, this graph is always going down, which means decrease is like super awesome. You're like, always. And the interval for always is -infinity to infinity. And you should feel powerful. Or a lot of sideways 8-ish. Okay, so, a couple examples. Now, we're going to talk about relative extrema. Now, extrema is a Latin word. It's plural for extremum. And extremum is the nominative, neuter, singular, Latin. Let me tell you about it. If you think French and Spanish are hard, oh, wow. Okay, so now, like you're used to verbs changing with like different tenses and different subjects. In French and Spanish and Japanese a little bit, verbs change their tense and their endings, and you conjugate them, and that's kind of a thing that people freak out about in French or Spanish at first. In Japanese, you're just constantly freaked out about what you're trying to learn. But in other languages like German and Latin, the nouns also change their ending, just for fun along the way, depending on whether... Okay, you really don't care. It's extrema. So, oopsie daisy. I went too fast, too far. A maximum is a spot where every other spot on it is lower, and a minimum is a spot where every other spot nearby is higher. That might sound backwards until you look at one, and then it's not that bad. So, Example 5, you might say, hey, I've seen this before. And the answer is you have, but now the question's different. So we're going to do relative minima. There is one relative minimum, which I circled. And this time you're going to write the point. So it's going to be 3, 3. Okay, super annoying thing. These answers, like points, they look just like intervals, right? 3, 3 with parentheses around it. So the parentheses with the two numbers with a comma that looks like an interval, and then you say, but this one is actually a point, like back when Algebra 1 was easy. Okay, relative maxima. There's one maximum, which I circled for you, and it's at 6, 9. It's a point. It's the biggest spot nearby. Okay, not so bad. Oh, except the endpoints, you might say, that left endpoint is a maximum because it's bigger than the spots nearby. But there's a special rule that say endpoints can't be relative maxima or relative minima. So neither of those endpoints, as beautiful as they are allowed to be extrema, relative extrema. Okay, let's look at this one. We've got relative minima. Let's see here. No, we don't, actually. We don't have any kind of endpoints, but then again, that doesn't really matter because the endpoints aren't allowed to be relative minima or relative maxima. But there also aren't any spots that are bigger than all the other spots nearby. That's worth thinking about again as you look at this. There aren't any spots on the graph that are bigger or smaller than all the other spots nearby. So there's no minima, there's also no maxima. So there's no extrema, but oh well. Okay, example 7, y equals negative x squared. We can totally graph that. That's our favorite parabola. It's just upside down. Okay, not so bad. Relative minima. No, there are no spots that are smaller than all the other spots nearby. Relative maxima. Yes, that one right there. Right there with the green circle around it. That is a maximum. That is bigger than all the other spots nearby. So 0, 0 is a relative maximum here. Okay, y equals 1/2 x minus 4. So we've got a y-intercept of negative 4. We've got a slope of 1/2. We've got arrows on the end. You may notice I gave you examples of graphing lines twice with slopes and intercepts. One with a positive slope, one with a negative slope. I'm kind of proud of how sly I am trying to make you review that on the side. Hey, minima. There are no spots smaller than any other spot nearby. Maximum. There are no spots larger than any other spot nearby. That's it. So that should give you a little bit of practice on ideas of how intervals work, how to write them for increase and decrease, and then how to identify relative maxima and relative minima. When you come back to class, you will find worksheet 3 waiting for you. When you do that, you will get some practice in these things. You will also find some good practice on domain and range. If you absolutely just cannot wait for worksheet 3 because you feel like your life is just, you're missing something, it's available on my website now, so you could get it now if you wanted. But there's no expectation that you've started. It's not like it's some sort of test on how serious you are or anything like that. If you're just kicking it and you want to get started, go for it. Otherwise, just come back to class prepared. We will enjoy worksheet 3 together. Thank you for your time. Thank you for watching, and please never hesitate to let me know if you have any questions. Goodbye.